Sathyabama Institute of Science and Technology.
Hello everyone, I am Dr.E.Priyadarshini, Professor, Maths Department, Sathyabama Institute of Science and Technology, deemed to be University. Today, I will be presenting correlation analysis. So, what is correlation analysis? Correlation refers to the combination of two words, that is co and relation, between two quantities x and y. Correlation is a statistical technique which is used to determine the degree to which the two variables are correlated. Correlation describes the strength of the linear relationship between the variables, and you should remember that linear means a straight line. The quantities x and y vary in such a way that the change in one variable corresponds to a change in the other variable. Then the two variables x and y are said to be correlated. For example, you can take the price of crude oil and the stock price of an oil producing company, price of commodity, the amount of demand, years of experience and the salary of the employees, dividend and the premium of shares, population and national income. These are some of the examples of correlation. The types of correlation. There are three types of correlation. One is positive correlation, the other one is negative correlation, and the third one is no correlation, or it can also be called as zero correlation. Now we'll come to the first one, which is positive correlation. If an increase in the value of one variable x, it gives an increase in the other variable y and vice versa, then we call it as a positive correlation. That is, both should go in the same direction. For example, the more time that we spend on a treadmill, the more calories will be burnt. The advertisement cost and the sales, they are directly proportional. Temperature and the ice cream sales, height and the weight of the person. These are some examples of positive correlation. Next is negative correlation. If the increase in the value of one variable x corresponds to a decrease in the value of the next variable y, then we call it as a negative correlation. That is, they go in the opposite direction and vice versa also. That means if there is a decrease in the value of one variable, it causes an increase in the value of the other variable. For example, the demand of a commodity and its price, tax and dividend, volume and the pressure of a gas. The last one is no correlation. That is, if the change in the value of one variable does not cause any change in the value of the other variable, then we call it as no correlation or zero correlation. For example, shoe size and salary, weight of a person and the color of his hair, height and intelligence. So these do not have any significance. Next one is you will have the scatter diagram. One of the graphical representation of correlation can be done using scatter diagram. For the scatter diagram, you require rectangular coordinate, x-axis and the y-axis, two quantitative variables. One variable x is said to be independent variable and the other variable is said to be a dependent variable which is dependent on the variable x. And the points are not joined together, they are scattered all over the plane and there will be no frequency table. So this is an example of a scatter diagram. So for the values for x variable is the weight of a person and y variable is the BP or SBP represents the blood pressure of a person. So that is plotted against the x-axis and the y-axis and these are the points that are plotted on the graph. Then comes the relationships. So depending on the plotting of the point, we can again divide it into three divisions. One is the positive correlation, the next one negative and the other one is no relationship. So you will have, this is the example for positive correlation. So if you plot the points, the lines are going from the bottom to the top, then we call it as a positive correlation. Suppose if the points are going from the top to the bottom, then we say it as a negative relationship using the, for this we have taken example age of a car. As the age of the car increases, the reliability of the car also decreases. Therefore, this is negative correlation. And next one is no correlation, that is pulse rate and weight. If you take it is scattered all over the plane, then it is said to be a scatter diagram. So next is we will find out about the correlation coefficient R. Correlation coefficient R, it quantifies the relationship between the two variables x and y. It can either be positive or it can be negative or it can be 0 also, and it lies between -1 and +1. The value of the number indicates the strength of the relationship. Now, the simple correlation, there are many types of correlation. You have simple, you have multiple, partial, etc. So, here we will be doing only the simple correlation coefficient, and it is represented by the letter small r. Now, this is also called the Pearson's correlation or the product moment correlation coefficient. It measures the nature and the strength between the two variables of the quantitative type. The sign of this R represents the nature of the association, and similarly the value of R, it indicates the strength of the association. If the sign is positive, then this means that the relation is a direct one. That is, if the increase in one variable causes an increase in the other variable. If the sign is negative, then it causes a indirect relationship or inverse relationship, that is, the increase in one causes a decrease in the other. Now, this is a ready-made table in which you will be able to find out about the relationship and also how strong the relationship is. So, here if it takes a value -1, it is one end and the next one +1 is in the other end. So, R lies between these two ranges, and suppose if it is R equal to 0, it is said to have no relationship or no correlation. If it is -1, it is a perfect correlation, negative correlation, and if it is +1, it is perfect positive correlation. And these values from -1 to 0, they are called indirect, and 0 to 1 is called direct correlation. So, this gives you a ready reckoner of how the values can be interpreted. If R is 0, that means there is no relationship. If R lies between 0 and 0.25, it is said to have a weak correlation. 0.25 to 0.75, intermediate correlation. 0.75 to 1 is strong correlation, and R equal to 1 gives you a perfect correlation. And this is the formula that we will be using to find out the correlation coefficient R. That is sigma xy minus sigma x sigma y divided by n, the whole thing divided by square root of summation x square minus summation x the whole square by n into square root of sigma y square minus sigma y the whole square by n. So, now I will give you an example of how to solve the problem. Here a sample of 6 children are selected and the data are all recorded. For x variable, the x variable is the age and the y variable is the weight in kilograms, and these are given in the table like this. Okay, now we are required to find out the correlation between age and weight. So, here we have got a serial number 1, 2, 3, 4, 5, 6 and age also 7, 6, 8, 5, 6, 9, weight 12, 8, 12, 10, 11, 30. Okay. So, now we will calculate the correlation coefficient. Already I told you the formula, this is the R and that we are going to calculate. So, what are the things we require for finding out this R? We require sigma xy, we require sigma x, sigma y, also sigma x square we need, and also sigma y square. So, these things we will calculate. See, here we have got x values, y values, then xy. Xy is, you have to multiply the second column with the third column, that is x multiplied with y gives you xy column, squaring the second column gives you x square column, and squaring the third column gives you the y square column. After that, we have to take the summation for all the values, that is summation of x, summation of y, summation of xy, summation of x square, summation of y square. So, after you do that, we have to substitute it in the R formula. So, when you substitute in the R formula, we get R to be 0.759. Okay, it is a positive correlation because the the sign that we have here is plus. So it's a positive correlation, and also it is a strong direct correlation. Why it is strong? Because it lies between 0.75 and +1. So the next example is the relationship between anxiety and the test scores. So you have got a anxiety score and the test score. So this will be treated as your x, this will be y. You have to find out x square, y square, then xy, and then take the total for all the columns. All the 5 columns we will be finding out the total, and then we'll substitute it in the R formula. So when we substitute it in the R formula, we get the value to be minus 0.94. So what is the indication here? The indication here is it is a negative correlation. And how is the strength of the relationship? It lies between -1 and 0, and it is very near -1. Therefore, it has got an indirect strong correlation. Okay, so now we have seen how to find out the correlation coefficient R and find out the nature as well as the strength of the relationship. In the coming videos, we will be discussing about the other methods that we will be using for finding out the correlation. For example, the Spearman's rank correlation. So thank you very much.